Good day, this is the project presentation of subject BFC35303 Water System Design and Management. So our lecturer is Dr. Muhammad Baharuddin bin Rizwan and also Dr. Muhammad Azlam bin Muhammad Yusof. So this is the members of Group 2 Section 5, which are Teheng Yu, Lizing Adia Izati binti Adi Izani, No Ain Shahira binti Mayudin, Basandra Baskara, and also No Alia binti Abdul Razak. So this is Lizing presenting the introduction of the project. Our project is to develop a 16 acres agricultural land at Serigading Berpa into a residential area. We are going to design the water system for the project, including the water supply design, the pressure demand, the sewage design, composite drain design, and also the erosion and sediment control of the project. So this is the development elements in the project, which are 112 units of single-story terrace house, 12 units of single-story bungalow, 1 reservoir water tank, 1 sewage treatment plant, and also 1 playground area. So this is the layout plan for the single-story terrace house, which is 7.32 in width and 21.34 meter in length. This is the single-story bungalow with 18.23 meter in width and 30.48 meters in length. This is all about the introduction. Thank you.
My name is Teheng Yu. I will cover the part of water supply system design. So first we calculate the demand population for this project. We obtain the demand needed is 169,600 liters per day for 112 units of single-story house and 12 units of bungalow. Later we calculate the peak flow and the fire flow, and we will choose the highest value one as the flow rate design. So the fire flow is higher, so we will use this value, which is 1.8 million 11,200 liters per day as the Q design, flow rate design. Later we calculate the height at which the reservoir water tank must be built. So the total water level is 6 meter, minimum residential heat is 7.6 meter. So we obtain the residential heat is 13.6 meter. And then we're using the Hazen-Williams equation to find the heat loss with this information. So we obtain the heat loss is 0.15 meter. So the residential heat plus the total heat loss, we obtain the requirement height of reservoir is 14.10 meter. So a minimum 14.10 meter height of reservoir must be placed to generate enough water pressure to supply 112 units of single-story house and 12 units of bungalow with 150 mm HDPE pipe and with flow rate 0.002 meter cube per second. That's all for me. Thank you.
Assalamualaikum and a very good day. My name is Nur Aisha Ravindran with metric number DF20107. We'll continue the presentation with sewage design. So what we need to do is calculate the design of the sewage system for the proposed residential area. So for this residential area, there are 124 units multiplied with 5, which is 620. So the total population equivalent will be 620. So by using table plant treatment capacity, PE of 620 equal to STP classified as class 1. Then, using table land area requirement for class 1, PE of 620 equal to the land area requirement for STP development is 835 meters squared. Referring to guideline of buffer zone distance with habitable buildings is minimum 30 meter. And the pipe material we are using is ductile iron, which have many coefficient with 0.012. So this is example for one of the calculation, which is MH1 to MH2. Population online is 18 units times 5 equal to 90, and then we calculate the dry weather flow, which is DWL, that we get 0.23 liter per second, and then peak flow factor, which is 6.13. Peak DWF is 1.41 liter per square, and the diameter of sewer 0.24 meter, condition full pipe flow area which is 0.04 meter squared, water parameter P equal to 0.71 meter, hydraulic radius which is 0.06 meter, gradient which is 0.005. And now we calculate for the velocity which is 0.9 meter per second. Within the range of 0.8 until 4 and bigger than sediment cleaning velocity which is 0.8 meters squared, which is okay. So the maximum flow rate Q is 36 liter per square, which is bigger than peak DWF, which is okay. The length of the sewer is 60 meter, fall equal to 0.3 meter, ground level equal to 20 meter, upper inflow level 19.5, and then the average depth which is 0.5 meter, and the last one is the lower evert level which is 19.2 meter. So this is the sewage reticulation design in a table. This is the overall result for the calculation of the design of sewage. So that's all from me. Thank you.
Hi, my name is Adila Izzati. Today I'm going to explain about the composite drain. There are many criteria for design drainage. The first one is the depth for reinforced concrete drain must be more than 0.6 meter. Okay, the width must vary between 0.6 to 1.2 meter. And then the side slope for concrete must be vertical. Freeboard must be 50 mm for the velocity. It has to be more than 0.6 meter per second to prevent sedimentation and vegetative growth. For the maximum flow velocity in open drain is 2 meter per second. So the first step is to determine the design flow for composite drain. Okay, the left side is the info. The first one is we have to find the intensity, which is 131.18 mm per hour. For the peak flow, we get 1.53 meter cube per second. Q dry weather, get 0.23 meter cube per second. Okay, the second step is calculate size of line drain section. Manning's N for concrete lining is 0.015. We assume drain longitudinal slope is 0.5. Drain width is 0.6. Okay, the side slope is 0. This is results. The provided dimension for line drain, the drain width is 0.6 meter. And then depth is 0.3 meter, velocity is 13.31 meter per second, and then for the Q is 2.4 meter cube per second. Last step is calculate size of total drain section. We use the Manning's N for concrete lining is 0.015 and then 0.035 for stone pitching. The left side is the calculation and the results in a table form. Figure in the right side is the drain that has been calculated and composed in the diagram form. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Naala bin Rosa and my number metric is TF200-144. And I would like to present about Chapter 5, Erosion and Sediment Control. So, government agencies in Malaysia have published many manuals or guidelines to pertaining the erosion and sediment control. These guidelines are meant to help the clients comprising the land developers or farmers to become the references of government agency. Nonetheless, sediment loading from land development is one of the most significant ecological consequences of development, not because these measures do not work, but because they are frequently adopted. And as a result, Malaysia's most effective control mechanism against this problem is to strictly enforce the requirement of an ESCPC, Erosion and Sediment Control Plan. Next slide is the erosion that could happen at our location is the rail erosion and the tunnel erosion. The general principle of ESCP preparation for the erosion and sediment control measure. And the slide is the general guideline for ESCP. That slide is the minimizing soil erosion, drainage control and runoff management, and earthwork and erosion control. These are the measures that could be taken to control the erosion and sediment control. Chapters is the ways and prevention to control the sediment and erosion control. The first one is sediment prevention and control. The second is slope stabilization. The third one is prepare project plan. And the fourth is engineering, design, and calculation. Thank you so much from me.
Hi, my name is Vasunthra Bhaskaran. I'll be presenting the conclusion part. What is conclusion? Conclusion by compliance with the project's requirement, we created a concrete water tank and also septic tank. For the Sri Gading Batu Pahat proposed building design, when it comes to designing water system, standard procedures in Malaysia include evaluating the availability and also the quality of water sources, figuring out the water demand of the area to be served, choosing the best treatment technologies and also distribution strategies, and designing infrastructures like pipeline, pumping stations, and also storage facilities.